I'm Lisa Potter with the University of Utah Communications Office, and I'm here with Richard Brown, Dean of the College of Engineering. And we're going to talk about the amazing growth and the amazing productivity that the College of Engineering is contributing to Utah and contributing to the nation. So can you tell me a little bit first about the state of engineering in Utah and in the United States?
Well, it's the 21st century, and this is the century of technology. So not just here in Utah, but across the country and the world, technology has really taken off. In Utah in particular, technology is really growing. In fact, Utah has the fastest growing tech sector in the country. If you go back to the year 2000, we had 1,500 high-tech companies in Utah. Now there are 6,700.
Wow.
Technology represents more than 10% of Utah's gross domestic product. So there is a great need for people who are educated as engineers and computer scientists in order to fill the jobs at these companies. And in fact, not just fill jobs, but create jobs. In the College of Engineering, if we go back from 2006 to present, the College of Engineering has spun out 74 companies. That's pretty amazing.
Yes, that's pretty crazy.
So there's a lot of growth. We've tried to meet that largely through a program the state of Utah has had called the Engineering Initiative. The Engineering Initiative started in 2000 when our governor at that time, Mike Leavitt, had a vision for Utah of developing a high-tech economy here. And in 1999, our College of Engineering graduated 366 students.
Really?
This past year we graduated 1,048. So there has been a huge growth.
Yeah.
In those days we were doing about $25 million worth of externally funded research a year. And this past year it was $95.8 million in externally funded research. So there's been a huge growth in the College of Engineering.
Yeah, and it seems like the growth has certainly provided a lot of opportunities for students to, graduate with an amazing education, but also be really well placed to, have companies to apply
That is
for.
true. There's a group that keeps track of starting salaries for people graduating different disciplines. 12 of the top 12 are engineering and computer science. There's so much demand for these people that it's not a question of do they get a job, it's how many job offers do they get. So it's virtually 100% placement.
Yeah, that's amazing. And I think about, like you mentioned, computer engineering, software development. I think about engineering, and I don't know, maybe I think about robotics, but the College of Engineering has a ton of diverse types of research and types of field.
Right.
Can you talk a little bit about all the different stuff that we do?
Engineering is really broad.
Yeah.
People sometimes wonder, what is engineering? Well, it's built on a foundation of science and math and chemistry. But I like a quote from a well-known aeronautical engineer, Theodore Van Karman, who said, "Scientists discover the world that exists. Engineers create the world that never was." What it's all about is serving humanity to raise our quality of life. So engineers develop virtually everything that we see. Smartphones, buildings, bridges, roads, cars, airplanes, they're all developed by engineers. There's a lot of focus on improving the environment, but engineers are involved in things as broad as entertainment. You're probably aware that one of our graduates, Ed Catmull, was the founder of Pixar Animation. And I think you probably grew up in the Pixar era and saw a lot of Pixar movies.
Sure did.
And now most movies that are made have an awful lot of computer-generated content in them. There's a big focus in engineering on energy. We want energy to be clean and to use it efficiently. But engineers and computer scientists have also had a huge impact on efficiency. If you think about our standard of living, so much of it is dependent on how much work each person can do. And computers have made a huge difference in our productivity. We use them, all of us, every day. Another thing is healthcare. The University of Utah has a wonderful College of Medicine, and there's a lot of interaction between medicine and engineering. Healthcare has become very technological too. And so we have people here who work on brain-computer interfaces. Artificial organs were pioneered here by Willem Kalf at the University of Utah in our bioengineering department. And there are many, many other examples of engineering and medicine working together.
Right. And that kind of brings us to where we're sitting right now. One of the amazing things about the College of Engineering is that, I mean, a huge draw is the amazing facilities that we have here. Can you talk a little bit about what a University of Utah engineering student might enjoy that perhaps they wouldn't enjoy at other institutions?
I'm happy to do that. You're right, this building we're sitting in is the USTAR building, the Sorensen Biomedical Technology building. It was funded through a wonderful state program called USTAR that provided $100 million to build this building. The university still had to raise money beyond that. But this building is all about research. We have here what we call the NanoFab, which consists of 2 large laboratories. The clean room, which is right next door to us, is about 18,000 square feet. 7,000 square feet of that is under HEPA filters, so it's very clean space. The rest of it is support space. And we're sitting in the surface analysis lab, which is 5,000 square feet of rooms like this with very expensive pieces of equipment, like this focused ion beam system to my right. Each of these pieces of equipment costs about $1 million. So there's a lot of expensive equipment here. This is really the machine shop of the future. It's the kind of equipment that's needed in order to make sensors and circuits that make it possible to better control our environment and help in healthcare and provide clean water and food and so on. You might have heard of the Internet of Things. The Internet is actually expanding to connect to many small devices that are sensing or controlling the environment. And this is the kind of facilities that are needed to build those devices. Speaking of the Internet, you might be interested to know that the University of Utah was the 4th node on the ARPANET, which is the predecessor of the Internet.
Right.
So we have a great history in computer science here. The University of Utah also pioneered computer graphics. So there are many reasons for a student to come here. I would say, you mentioned facilities.
Mm-hmm.
I would add the equipment, but the most important reason to come here is the faculty, because this is a research university. The Carnegie Foundation categorizes universities into a number of different types of universities, from teaching universities up to research university. The highest category is research university with very high research. The University of Utah is in that category. It's the only one in Utah that is. And so our faculty are really at the leading edge of research in their own disciplines. So students get to be taught by people who are involved in developing new knowledge, presenting it at conferences, publishing it in journals, and bringing it right into the classroom.
Right, and you talked about in the beginning, you know, from the last 10 years or so, how much the faculty's grown and the research has grown, and so it's every year, it seems like
better than it was the year before.
Exactly.
That's right. We try to make sure that every student has some kind of a signature experience. And in engineering, every student does a senior project where they actually design and develop some new widget, depending on which discipline they're in. These are done in many cases in conjunction with industry. I remember we had a banquet a few years ago and had the president of Rocky Mountain Power as the speaker. And his company had financed and sponsored one of these projects in electrical and computer engineering. And he said that by the time the semester was over, they had the equipment installed and helping to manage the power distribution
Really?
in the valley.
That's
So they work on real projects.
yeah, that's so cool. And just while we're talking about real projects, because what we talked about behind us, one of these images I thought would be so interesting to talk about again.
Sure.
I don't, know if you can see these images behind us. So these,
Right.
I'll let Dr. Brown.
This is an image of the Utah Array, which is a brain-computer interface. And you can see they're very small. Well, you can't tell that they're very small, but take my word on it. These are very small needles, and the points of them are conductive, and the shank is insulating. So this is an array of probes that can be impaled into a human brain, and these tips will get the electrical signals from an individual neuron. So this allows researchers to look inside of a person's brain. And it turns out that this is the only FDA-approved brain-computer interface, to my knowledge. So whenever you see on a television show or a news program some person operating a robotic arm to bring a cup of coffee to them or something like that, you can be sure they have the Utah Array in their brain. So Utah's been a leader in this technology for 20 or more years. There's actually been a lot of research done here at the University of Utah on the connection between medicine and engineering. I've even had some students myself who built brain probes. I got my PhD at the University of Utah.
That's right.
In electrical engineering, but my dissertation work was developing solid-state chemical sensors.
Right.
So many years later, some of my students were the first ones to add chemical sensors to brain probes. So, as everyone knows, the chemical signals in the brain are a very important part of what's going on there. So I viewed it like adding color to black and white photography.
Yeah.
So we built several types of brain probes that looked at both electrical and chemical signals. And then the last project in that line of research, we decided that the brain really doesn't like foreign objects stuck in it. And so we wondered how much information we could get just from the surface of the brain. And we put an array of microelectrodes on the surface of the brain. And we were able to distinguish 10 different spoken words just from the signals on the surface of the brain.
Like the signals could somehow map what words were being spoken by the patterns? Crazy.
We put our electrodes on the face motor cortex. This was done in conjunction with neurosurgeon Paul House in the medical school. And we had the subjects speak different words, and we used principal component analysis. You may not care about the detail, but we bend the energy in different frequencies from different electrodes, and we were able to tell, were they saying hot or cold, yes or no, and so on.
That's
I
crazy.
thought, you know, there are people who have what they call locked-in syndrome. There are a number of different diseases that make it so even though a person's brain is working fine, they're thinking, they can't move a muscle, they can't speak. In fact, I had a good friend who had Lou Gehrig's disease, and I watched him go through this. And I thought, wouldn't it be wonderful if you could give a patient like that a vocabulary of even 50 words
Yeah.
that would change their quality of life a great deal.
Right. That's amazing.
Anyway, there was a lot of
Yeah.
exciting work going on in engineering at the University of Utah.
Yeah, absolutely. And one more image that I think is really cool to show the precision of what we can do in the amazing nano scale. Right here. Do you want to explain what this is?
Those are red blood cells, human red blood cells, and you'll notice that they have a block U written on them. This piece of equipment behind us is a focused ion beam system, and it is able to deposit material or etch material on a very fine scale. And in this case, it etched material from the surface of the red blood cells to put a block U on them. Now, it may be that many of us who work here have those block U's on our red blood cells, and we just don't know it.
Yes.
But anyway, that shows you the precision. Those blood cells are probably 6 or 7 microns in diameter.
Yeah, that's crazy. I mean, I think we've got a great overview of engineering. Are there any specific other things that you wanted to talk about, any programs?
Well, we have some very exciting new research projects that have started just this year. One of them is called Powder, living in Utah.
Right.
Seemed like an appropriate name.
You know your audience.
That's right. Powder is run out of our Flux group in the School of Computing, and it's a test bed for wireless communication. You may have noticed that wireless standards keep evolving. We get higher bandwidths, we get better performance in many ways. So this test bed will support emerging wireless technologies, and it is going to cover all of the University of Utah campus and most of downtown Salt Lake City. So there'll be transponders on buses and tracks, trains, and on buildings, and people will be able to try out their new wireless technologies in this environment. This Flux group is spectacular at building test beds.
Yeah. And it's a whole test city.
That's right. Another exciting project is called Forge. It is from our Energy and Geosciences Institute, which is closely affiliated with civil engineering and with chemical engineering. And their project, Forge, is a geothermal project. They're drilling a well just north of Milford, Utah. The well, as I understand it, goes down 8,000 feet, and then it goes horizontal about 12,000 feet. That's a place where the rock is very hot, close to the surface. So they'll drill a second well on top of the first and frack the rock between. Then they pump water down one hole, pump it out the other, and it comes up very hot so that you can generate electricity as it flashes into steam. That is probably as big a research project as the University of Utah has ever had. I'm proud to say that we beat out some very stiff competition to get that project. Sandia National Laboratory was one of the competitors for that. They had some other very good partners. But that project will result in about $140 million total to the university to do that project.
Yeah, that's amazing. Well, I mean, is there anything else or that you can think of?
Engineering is a very exciting field to be in. It's a place where people get great job satisfaction because they're able to invent things that improve life for all of humanity. And that's a gratifying kind of job to have.
Yeah, absolutely. Well, thank you so much for telling us about the college. We really appreciate it. Yeah, thank you all
My
for.
pleasure. Thank you.
Thanks for watching.